Hello! Welcome to Teach Me Maths. My name is Jonathan Hicks and today we're doing indices. Sometimes these are called powers, but it's a very important topic. There are three topics you really need to know well before you can cope with algebra later on. That's fractions, negative numbers and indices. And in some ways indices can be the most challenging. I'm going to cover all the different key laws of indices, as they're called, that you need particularly for algebra. But there's a lot to go through, so we're just going to dive right in. So, I should say before we do, you need to understand square and cube numbers. So if you're not sure about squaring and cubing, go and watch the square and cube numbers video first, and then come back here. Alright, so I'm going to pick 2 as my base number throughout this. This is the number we're going to be squaring or cubing or raising to other powers. So 2 squared, if you remember, that means 2 times 2, that's just going to be 4. 2 cubed, so you put a little 3 at the top right, that means you've got 3 2's all multiplying together. That's going to give you 8. Yeah, 2 times 2 is 4, times that by another 2, you're going to get 8. Again, just be very careful here. 2 cubed doesn't mean 3 times 2. It means there are 3 2's that are all multiplying each other. 3 times 2 would be 6, but this is 8. It is different, very different. Now the power, as it's called, the 2 here or the 3 here, can actually be any number you like. So you can have 2 squared, you can have 2 cubed, and you can also have what we call 2 to the power 4. That just means you've got 4 2's instead of 3 2's. So that's 2 times 2 times 2 times another 2. Well, 2 times 2 is 4, times that by 2 you get 8, times that by 2 you get 16. So we would say 2 to the power 4 is 16. You can carry on. So 2 to the 5, I won't bother writing out all the 2's, but hopefully you can see here that you're going to get 5 2's multiplying together, and that's going to give you 32. Hopefully you can see that each time we add an extra 2, the number just gets twice as big. We had 2 times 2, which is 4, times it by another 2, it's going to be twice as big. Times that by another 2, it's going to be twice as big again. If you've got 5 2's multiplying, it's going to be twice as big again. And you can keep going. So imagine you had 2 to the power 10 or something. Now I'm not going to write all these out, but basically it means you've got 10 2's all multiplying together. 2 times 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 2. And if you multiply all those 10's together, all those 2's together, then I think you'll get 1024. So these numbers can get very big. And it's interesting that you don't have to make the power very big before you really start to get some very big numbers coming out. So powers ramp up really fast. And now there's a couple of things you can do with powers. That's the basic concept. So let's imagine you've got, let's have 2 to the power 4 times 2 to the power 6. Now what that means is 2 to the power 4 is 2 times 2 times 2 times 2, and then we're going to times that by 2 to the power 6, which is 2 times 2 times 2 times 2 times 2 times 1 more 2. There we go, 6 2's multiplying together. So actually you've just got 4 and 6 makes 10 2's multiplying. So another way of writing all of that would just be 2 to the power 10. Yeah, the power, remember, tells you how many of these things you're multiplying. 2 to the power 4 means you've got 4 2's multiplying. 2 to the power 6 means 6 2's multiplying. So if you've got 10 2's multiplying, it's just 2 to the power 10, which we saw before was 1024. So you can work it out, but the key thing here is that if you're multiplying, you've probably seen here, 4 of them plus 6 of them just gives you 10 of them. So actually you're adding the powers, because you've got 4 plus 6 to give you 10 altogether. And that's our first law of indices. If you're multiplying, and it only works if you've got a multiplication symbol here. If I change the symbol in the middle here to a minus or something, then I've no longer got 10 2's multiplying. I've got 4 and then some big horrible subtraction sign in the middle, which means it doesn't work. It's got to be multiplication. But if you're multiplying two numbers that have got powers, you just add the powers. 4 plus 6 gives you 10. Another important point here is that the base number, the 2 in this case, must be the same. if I had 4 3's multiplying, if this was 3 times 3 times 3 times 3, and then a whole load of 2's multiplying, I couldn't combine them. It only works because they're all 2's and it's multiplying all the way along. So if you're multiplying with powers and the base numbers are the same, you just add the powers. That is our first law of indices. Alright, so that was multiplying, but there's something else we can do here, which is, get rid of that, we can divide. So imagine I've got 2 to the power 6 divided by 2 squared, let's say. So, because it's a division, you can write this as a fraction. And in general in maths, we prefer fractions to this division sign. This division sign is a bit old-fashioned, it can be a little bit ambiguous, and I try not to use it if possible. You're always better off writing it as a fraction. So actually I'm going to go underneath here, I think. So I'll have 2 to the power 6 divided by, that's what the fraction line means, it means divided by 2 squared. So 2 to the power 6 is 2 times 2, 6 times 6, yep, divided by 2 squared, well that's 2 times 2. You've got 2 2's multiplying. And because it's a fraction, we can cancel. Remember, you can divide the top and the bottom by the same thing. So because I've got a 2 here and a 2 here, I could divide the top and bottom by 2. Effectively, I can just cancel each of those 2's. And I could cancel these 2's as well. So that 2 will cancel with that 2. So actually, 2 to the power 6 divided by 2 squared, I don't need to work out what 2 to the power 6 is, and then work out what 2 squared is, because these 2 on the bottom from the 2 squared are just going to cancel with 2 of the ones from the 2 to the power 6. So what you're going to end up with is 4 2's multiplying, which is 2 to the power 4. So 2 to the power 6 divided by 2 squared is 2 to the power 4. And again, you can see we're just subtracting the powers here. Because the ones on the bottom, the 2 squared, cancel with 2 of the ones from the top, you've got to take these 2 away from here to leave you with 4. So I can just work out what 2 to the power 4 is, well that's 16, without having to work out what these are. So these multiplication and division rules just tend to make life easier for yourself, because you often can simplify the calculation and end up with something that's easier to work out. So that's your second law of indices. If you're dividing, you subtract the powers. So first law of indices, when you're multiplying and the base numbers are the same, you add the indices. You add the powers. If you're dividing, and again the base numbers must be the same, then you subtract the powers. It's always the first one minus the second one. 6 minus 2 gives you 4. And that's why. Alright, so those are our first 2 laws of indices. We've been increasing the power here, 2 squared, 2 cubed, 2 to the power 4, 5, 6, 7, 8, 9, 10, etc. And you can go on as far as you like really, but the numbers do get very big very quickly. But you can go the other way as well. So if we had 4, 3, 2, you could have 2 to the power 1. Well, if 2 to the power 4 gives you 4 2's, and 2 cubed is 3, and 2 squared is 2, well 2 to the power 1 is just one of them. So it's just 2. And that turns out to be so important that it is the third law of indices. 2 to the power 1 is just 2. And in fact, it doesn't really matter what this number is here. Anything to the power 1 is whatever it is, because you've got one of them. So for example, I'll perhaps use this space here. So if you've got 7 to the power 1, well, that's just 7. If you've got minus 3/4 to the power 1, well, it's just minus 3/4. It doesn't matter what this is, how messy it is or horrible it looks. If it's to the power 1, it's just the thing itself. It's the thing itself, because the 1 means you've got one of these things. If I've got 1 minus 3/4, then I've got minus 3/4. So anything to the power 1 is itself. But, and sometimes more importantly, that rule works equally well the other way around. If you have a number, like 8 for example, and it doesn't have a power, it does really. Any number without a power actually has a power of 1, because there's one of them. So 8 has a kind of imaginary power 1 up there. So if you're doing 8 times 8 to the power 4, we're multiplying And when you're multiplying, you add the powers. So I take my imaginary 1 that's here and add it to the 4. So when you multiply these, you're going to get 8 to the power 5. Which makes sense if you think about it. If you've got 4 8s multiplying here, and you're multiplying by a 5th one, altogether you've got 5 of them. Yeah? But a lot of people forget that there's a power there. They think, add the powers, nothing plus 4 gives you 4. But it's not nothing. If a number doesn't have a power, it does really, and the power is 1. The other way around, anything to the power 1 is just itself. So that's your third law of indices. All right. Well, we can keep going. Let's have 2 to the power 3, 2, 1, 0. What's that going to be? Now, a lot of people tend to think that that should be 0. You've got 3 2s, 2 2s, 1 2, no 2s. So if all the 2s have gone, then you've got nothing, don't you? Well, actually, you don't. Let me try and explain why. Create a bit of space here. Now, when you're adding and subtracting, if everything cancels, you do get 0. So if you've got 3, and then you add 5, and then later on you subtract 3, and then later on you subtract 5, well, this 3 cancels with this minus 3. Yeah, that cancels. And the positive 5 here is going to cancel with the minus 5. So that cancels as well. So it's all cancelled. So you do end up with 0. When you're adding and subtracting, if everything cancels, you get 0. However, if you're multiplying and dividing and everything cancels, you don't get 0. Let me show you what happens. Imagine you've got 2 times 2 on the top and 2 times 2 on the bottom. So this 2 cancels with that 2, and this 2 cancels with that 2. So you've got, what have you got? Well, we have to look at this a little bit more carefully. What's actually happening when you cancel is that you say, how many times does 2 go into 2? Well, it goes once. And how many times does 2 go into 2? It goes once. We don't normally bother writing the little 1 there, because if you're multiplying by 1, it doesn't do anything. Times something by 1 and you've still got what you started with. And if you divide by 1, that doesn't do anything either. Anything divided by 1 is just the thing you started with. So most of the time we don't bother writing the 1s, we just cancel them. But if it all cancels, then you need these 1s here. 2's into 2 go once, and 2's into 2 go once. 1 times 1 on the top gives you 1. And 1 times 1 on the bottom gives you 1. And 1 divided by 1 is 1. If everything cancels, when you're multiplying and dividing, you don't get 0. You get 1. Which is quite counterintuitive, but that's the way it is. Now this 2 times 2 on the top and 2 times 2 on the bottom, I could have written that as 2 squared divided by 2 squared. Yeah, this is 2 squared and this is 2 squared. And if you're dividing, you subtract the powers. 2 minus 2 gives you 0. So whatever this lot is, it's got to be the same as 2 to the power 0, because 2 minus 2 is 0. This has got to be 2 to the power 0. So in fact, 2 to the power 0 is 1. Yeah, who'd have thought it? And that's the fourth rule of indices. Very important one. Anything to the power 0 is 1. And again, it doesn't actually matter what this is. The 0 here tells you that it's all cancelled. They've all disappeared. So you're just left with 1. So if you've got, again, 7 to the power 1, if you've got 7 to the power 0, anything to the power 0 is 1. All the 7s have cancelled. Yeah, you've got no 7s left here, so you've just got 1. And again, if you had minus 3/4 to the power 0, the 0 means all the minus 3/4 have cancelled. They've all disappeared. So you're just left with 1. When everything cancels, when you're multiplying and dividing, you are left with 1. So, first law of indices, when you're multiplying, you add the powers. Second law of indices, when you're dividing, you subtract the powers. Third law, anything to the power 1 is itself. And the fourth law of indices, anything to the power 0 is 1. Now there's one more law which is very important that I want to show you. I'm going to need a bit more space for this, so we'll perhaps rub these out, I think. Now we've had 2 cubed, 2 squared, 2 to the power 1, 2 to the power 0. Well, you can actually have negative powers as well. So imagine you've got 2 to the power minus 1. What does that mean? Well, if we come back to here, this will be a bit like having, imagine I had 2 squared here divided by 2 cubed. So I had an extra 2 on the bottom. 2 times 2 times 2. Now this 2 will cancel with this one. They're both going to become 1s. And this 2 cancels with this one. They're both going to become 1s. But this 2 has run out of 2's to cancel with. Because I've got one extra 2 on the bottom than I do on the top. Yep, there are 3 2's here and only 2 of them here. I've got one extra 2 left over on the bottom. So I've got 1 times 1 on the top, but I've got 2 times 1 times 1 on the bottom. So what you end up with, 2 times 1 times 1, is 2. So 2 squared divided by 2 cubed gives you a half. But again, if you subtract the powers here, 2 minus 3, you're dividing, so you subtract the powers. 2 minus 3 is minus 1. So 2 to the power minus 1, the minus here means you've got an extra 2 on the bottom. There were more 2's on the bottom than there were on the top. So extra 2 on the bottom gives you a half. Yeah. Right, let's go more negative. We'll have 2 to the power minus 2. Well, minus 2, again if I come back to here, if I made that a 4, 2 minus 4 will give me minus 2. And then we just got to work out what this is actually going to give us. So 2 squared on the top still, 2 to the 4 on the bottom, 1, 2, 3, 4. Those 2 will cancel with those 2 and become 1s. But these 2 2's have got nothing else to cancel with. There are 2 extra 2's on the bottom of the fraction. So they're going to be left here. You're going to end up with 2 times 2, which is 2 squared on the bottom. So if there are 2 extra 2's on the bottom, when you subtract the powers, you're going to get a minus 2. And that means you've got 2 extra 2's on the bottom. So 2 to the minus 2 is 1 over 2 squared. Let's do one more of these. So 2 to the minus 3. Well, again, I want to construct 2 to the minus 3. So, oops, not 3. I want a 5 here. Because 2 minus 5 will give me the minus 3 that I need. Yet when you subtract the powers, 2 minus 5 gives you minus 3. That means we're going to have 5 2's on the bottom here. 1, 2, 3, 4, 5. 2 of them cancel with those 2 to become 1s. But then I've got 3 extra 2's left over on the bottom. Yep, 2 minus 5. 3 extra 2's on the bottom. 1, 2, 3. That's 2 cubed. So the minus power here, in this case the minus 3, means I had 3 more 2's on the bottom than I did on the top. 2 minus 5 gives you minus 3. Here they are, the 3 extra 2's are on the bottom. And so that's going to become 2 cubed on the bottom. So 2 to the minus 3 is 1 over 2 cubed. And in general, if you've got 2 to the power of n, where n is whatever number you like, actually well, it's going to be a minus, so 2 to the power minus n, that's going to be 1 over that many of them. So it's 1 over 2 to the power n. The minus sign means you have that many 2's left over on the bottom. So there they are. It's 1 over exactly the same thing as you had here, but it's positive. So it doesn't matter what the power is. However many extra 2's you have on the bottom is indicated by how negative it is. And so you can rewrite it with them on the bottom. If you've got n extra 2's on the bottom, then you need to write n extra 2's on the bottom. So in general, again, because it doesn't really matter what the base number is, anything to the power which is negative, anything to a negative power, is 1 over the same thing but positive. You can think 1 over the positive. And that, finally, is our 5th law of indices. So again, quick recap. If you're multiplying, add the powers. If you're dividing, subtract the powers. Anything to the power 1 is itself. Anything to the power 0 is 1. And anything with a negative power, you can rewrite that as 1 over the positive. Okay, so that's the laws of indices. I've gone over some of that quite quickly. You really need to practice this. And so what I'm going to do is I'm going to do another video where I go through a bunch of practice questions using these laws of indices. But you really need to learn them. They're so important for algebra. Each of these 5 laws you need to know off by heart. In practice, math is a language. And if you just keep using it, if you keep practicing your maths, you'll find you don't need to memorize things very much. You'll just get to know them through familiarity. So this multiplying to add the powers rule, you often don't have to sit back and think, oh, what do I do here? If you've done it enough, you'll just know instinctively that you add the powers. So after enough practice, this does become quite easy. But to start with, I strongly recommend you learn each of these rules. Just say them over to yourself. Anything to the power 1 is itself. Anything to the power 0 is 1. But you really need to know these. They're so important for all of maths really, from the time you start algebra to through advanced maths and beyond. Okay, my name's Jonathan Hicks and you're watching Teach Me Maths.